Good morning, student. So today this is our second lecture on a gravitation. In the very first lecture we had seen the development of phenomena of gravitation, in which we had seen what are the contributions made by the Indian astronomer and mathematician, that is Aryabhat, because he had studied a lot regarding the planetary motion, that is motion of moon around the earth or motion of earth around the sun. Then John Tycho Brahe, he is not a scientist, he had simply recorded the motion of different planet in hundreds of books, and tons of data is available regarding the planetary motion surrounding to that of earth. And that entire tons of data of planetary motion, it were analyzed by John Kepler, and whatever may be the analysis of that planetary motion, John Kepler just formulated them in the form of three laws, and those three planetary laws of motion, they are known as law of orbit, law of area. In 1609 he had announced only two laws, law of orbit and law of areas, but after 10 years he had given the third law, that is known as a law of period. So whatever law is given by John Kepler, every planet, they are obeying that laws of planetary motion. But Kepler was unable to explain why every planet has to obey those three laws. So it was a Newton who had just given what? Newton has given the reason behind why the planet, they have to obey the planetary laws of motion. But during the same period of time, remember, as far as Galileo is concerned, Galileo has given most of the laws in physics. We may call Galileo as a father of physics. So, during the year 1665, when Galileo is doing his work on the motion of moon around the earth, he continues to study. And in the year 1665, Newton studied, not Galileo, during the same period, nearly in 1665, Galileo made a statement that when a lighter and the heavier objects, either a lighter object or a heavier objects, if heavier and lighter objects, they are released from same height, then both the object, no doubt, they move towards the earth, they get attracted towards the earth, and both of them, he said that both of them, they will reach the surface of earth at the same time. No one can believe. So what he had just done, on a leaning tower of Pisa, from the top of leaning tower of Pisa, he had released one very heavier object and other a very lighter object. Peoples are gathered surrounding to that leaning tower of Pisa, and everybody has just observed that heavier object as well as lighter object which were released from the same height, they will reach the surface of earth at a time. So Galileo said that all the material objects, they move towards the surface of earth with a constant acceleration, at a constant acceleration. Later on, and as far as the work of Galileo is concerned, still Galileo is also not in a position to explain why the planet, they will obey the planetary laws of motion. Means why all the planets, they will obey that planetary laws of motion given by a John Kepler. So Newton was that person. During the study of Newton, In 1665, Newton is studying the motion of moon around the earth. Newton is studying how the moon is performing its motion surrounding to that of earth. Newton has a clear-cut idea, means most of the people as well as Newton, they knows that moon will take nearly 27.3 days to complete its one revolution around the earth. Means the time period of moon around the earth, it is 27.3 days. Also, Newton notes that moon is at a distance of 3.58 into 10 to the power 5 kilometer from the center of the earth. Moon also performs a perfect circular motion along the circumference of circle of radius r equal to 3.58 into 10 to the power 5 kilometer with a constant angular speed. Angular speed of moon is what? Constant. Remember, when moon is revolving around the earth with a constant angular speed in a time period 27.3 days along the circumference of circle of radius 3.58 into 10 to the power 5 kilometer. Remember, as soon as he come to the conclusion that moon is performing circular motion, he knows very well for any object, say of mass m, to perform a circular motion, that object must be acted upon by certain force. That force must act along the radius of that circular orbit, and that force must be directed towards the center of the orbit. So, for an object of mass m, to perform the circular motion along the circumference of circular orbit of radius r with a constant angular speed omega, that object must be acted upon by a force which acts along the radius and directed towards the center. Such center seeking force is called centripetal force. Centripetal means center seeking, directed towards the center, and that centripetal force, it must be equal to what? mr into omega square, because centripetal force, it is mv square by r, where v represent the linear velocity of an object. That linear velocity of an object performing circular motion, it can be obtained just by drawing a tangent to the circle at the position of particle. So these arrows, they will represent the linear velocity. So centripetal force is equal to mv square by r, or it is mr omega square. Why it is so? Because v is equal to r omega, and if you put the value of v equal to r omega, mr square omega square upon r, one r get cancelled and you will have mr omega square. So, as moon is performing circular motion around the earth with constant angular speed omega, and if I just consider m is the mass of moon, r is the radius of circular orbit in which that moon is performing circular motion, and omega is the constant angular speed of a moon, then centripetal force acting on moon, it is mr omega square, mr omega square. But according to its own Newton's laws of motion, according to Newton's second law of motion, force acting on moon is equal to m into a, mass into acceleration. Here a represent the acceleration felt by moon. That acceleration will act along the line joining the moon and center of the dipole. That acceleration is directed towards the center of the earth. So we are having the two expression for force. Both of them, they are the force acting on moon. So you can equate their right hand side. So m into A is equal to mr omega square. So this m on two side get cancelled. So A is equal to r into omega square. Now what is this omega? Omega represent angular speed. Omega is what? Angular speed. Linear speed is equal to distance upon time. Angular speed is equal to angular distance upon the time. See here, when object is performing circular motion and when object moves from A to B, what is the angular displacement? 90. From B to C, object undergoes angular displacement of what? 180 degree. Means when object complete one oscillation, it undergoes a displacement of what? 360 degree. 360 degree means 2 pi radian. And the time taken by object to complete one revolution is called its time period, and it is denoted by a letter capital T. So here afterward, you always remember that angular speed is equal to angular displacement upon time. In a time of one revolution, that is in time period T, angular displacement is 2 pi. So here acceleration felt by moon or the acceleration acting on moon due to what? Due to Earth's gravitational force is A equal to R. Now what is R? It is the distance of moon from Earth center. What is the distance? Is 3.58 into 10 to the power 5 into. Now omega square. Omega means 2 pi by T whole square. So that is equal to 3.58 into 10 to the power 5. Now what is square of 2 pi? 4 pi square. Value of pi is 3.142 and whole divided by T. See here, moon takes a time of 27.3 days to complete one revolution around the earth. Means the time period of moon is 27.3 days. Convert that days into second. So 27.3 days. In one day, how many hours are there? 24 hours. In 1 hour, how many minutes are there? 60 minutes. In 1 minute, how many seconds are there? 60 seconds. So this entire will gives you the time period of a moon in terms of second and its square. He had calculated this tremendous tedious calculation, and this calculation, it comes to be 0.0027 meter per second. So the acceleration felt by a moon due to Earth's gravitational force, it is a 0.0027, which is very small as compared to that of acceleration due to gravity 9.8 meter per second square. This acceleration due to gravity, it is felt by most of the object near to the surface of Earth. So you may call it as A object. So whenever I will write A object, it means it is the acceleration felt by the different objects which are near to the surface of Earth. You may have this situation for object. Remember, object near to the surface of Earth, we are taking it granted that every object near to the surface of Earth, they will experiences or they will felt an acceleration. A object is equal to 9.8. It is constant for all the object. Why it is so? Because all the object near to the surface of Earth, if I measure their distance from the center of the Earth, there is a very slight variation. That variation is negligible. So because object near to the surface of earth, they are nearly at the same distance from the center of the earth. So that's why the acceleration felt by object near to the earth is constant, and that is equal to 9.8 meter per second square. But moon is also object, so we are expecting that moon must also have an object, moon must also have what? An acceleration due to gravity equal to what? 9.8. But the acceleration felt by moon due to what? Gravitational force of earth is found to be very, very small. So in front of Newton, both these calculations are there, that moon felt such a small acceleration due to gravitational force of earth, while all the objects near to the surface of earth, they were all having the same acceleration of 9.8 meter per second square. And from these he draws the conclusion that if object is far away from the earth's center, then its acceleration will decreases. So remember that Newton draws the conclusion that if object is far away from the earth's center, then the acceleration felt by that object, it must be decreasing. So acceleration felt by object will goes on decreasing as the distance of object from the center of earth, it will goes on increases. It will what? Goes on increases. So he had calculated the ratio of, now he had two values, that acceleration felt by object near to the surface of earth and the acceleration felt by moon. So acceleration felt by an object close to the surface of earth and the acceleration felt by moon. What is that acceleration felt by most of the object near to the surface of earth? It is 9.8 meter per second square upon. What is the acceleration felt by moon? Due to gravitational force of earth, it is very, very small, 0.0027, and if you calculate this fraction, it comes to be nearly 3600, because he just want to find out the relationship between how the acceleration decreases with increasing distance of object from the center of the earth. Distance of object from what? Center of the earth. Then he knows the radius of earth, he knows the distance of moon from the earth center. So distance of moon from what? From earth center. Distance of moon from earth center divided by distance of object from earth center. What is the distance of moon from the earth center? It is 3.58 into 10 to the power 5 kilometer, and the object near to the surface of earth, they are roughly at a distance equal to radius of earth, and that radius, it is 6378 kilometer. 6378 kilometer. And if you calculate it, it comes to be equal to what? 60. It comes to be equal to roughly 60. So here these two calculation, ratio of a object to a moon 3600, ratio of distance of moon upon distance of object, both from earth center, it is 60. So he draw the conclusion that a object upon a moon, which is 3600, I can write this as 60 square, but 60 is what? It is equal to distance of moon, distance of moon upon distance of object. Distance of moon upon distance of what? Object from the center of earth and its square. See here, distance of moon upon distance of object is 60. If I take square on both the side, then this square of 60 is 3600. So, he had a conclusion that a object is inversely proportional to what? Square of distance of that object from the center of the earth. Inversely proportional and its square. So, it means he come nearer to the inverse square law and he draw the conclusion from this calculation. What he made the conclusion? That according to Newton, that acceleration felt by an object. According to Newton, acceleration felt by an object due to gravitational force of earth is inversely proportional to square of distance of that object from the center of the earth. See, this is the important line. The acceleration felt by an object due to gravitational force of earth is inversely proportional to square of distance of that object from the center of the earth. Also, force F is equal to m into A. It means force exerted by earth on the object is proportional to, see here, it is proportional to mass of object, and this m is inversely m divided by r square. So what this F represent? It is the force exerted by earth on the object which is at a distance r from it, and here small m represent the mass of an object. But remember, Newton's law of gravitation, it is actually the mutual force of attraction that takes place between the two bodies by the virtue of their masses. So, as earth is exerting a force of attraction on the object, that object will also exert a force on the earth. Force exerted by the object on the earth, let it be denoted by F suffix E. So, it must be directly proportional to mass of earth and divided by square of distance of that object from the earth center, which is same. So, Newton had these two equations and he knows, because according to Newton's own third law of motion, force exerted by magnitude of force exerted by earth on the object, it must be equal to magnitude of force exerted by object on the earth, because they are forming what? Action reaction pair of forces. Action reaction pair of forces. So as F is equal to Fe, but F is proportional to mass of object, Fe is proportional to what? Mass of earth. So he draw the conclusion that the force exerted by earth on the object is proportional to both mass of earth as well as what? Mass of earth and mass of object, and it is inversely proportional to what? Square of distance of separation of that object from the earth center. So he generalized that the gravitational force of attraction between the earth and an object of mass m at a distance r from it is F is proportional to m into m divided by r square. Here m represent mass of earth, small m represent mass of what? An object. So after coming to this conclusion that the gravitational force exerted by earth on the object is proportional to what? The product of mass of earth and mass of object, and is inversely proportional to what? Square of distance of separation between the earth and that of what? Center of earth and that of what? Object. So he had now made a statement That statement is known as universal law of gravitation, because as far as F is proportional to m into m divided by r square is concerned, this is a natural law. He has generalized because he knows that whatever law is applicable for our nature, that law is applicable for the universe. So the existence of gravitational force of attraction between the two material objects is not only valid for earthly objects, but they are also valid for what? Celestial object. So that's why Newton's law of gravitation, because it is applicable for the material object which were lying anywhere in the universe, so that's why it is known as a universal law of gravitation. Now, what is the statement of universal law of gravitation? The exact statement will be like this: every particle of matter, what you can say, every particle of matter, every particle of matter attracts, every particle of matter attracts every other particle of matters, every other particle of matter, every particle of matter attracts every other particle of matter with a force, which is what? With a force which is directly proportional to, which is directly proportional to the product of their masses, directly proportional to the product means multiplication, directly proportional to the product of their masses, PHEIR, product of their masses, and is inversely proportional to 1 upon r square, is inversely proportional to, inversely proportional to the square of, inversely proportional to the square of distance between them, square of distance between them, square of distance between them. So let us confirm the exact statement word to word as per your textbook. Every particle of matter attracts every other particle of matter with a force which is directly proportional to product of their masses and is inversely proportional to the square of distance of separation between them, square of distance between them. So if we are having the two particles, say of masses m1 and that of m2, let these two particles, they are separated by a distance r. Then according to Newton's law of gravitation or universal law of gravitation, because these are the two particles having masses m1 and m2, it means there must be a gravitational force of attraction between them, and that gravitational force of attraction between the two particles of masses m1 and m2, that force is proportional to product of their masses. That gravitational force is proportional to, inversely proportional to square of distance of separation between them, and this gravitational force F is proportional to m1 m2 divided by what? R square, or this F is equal to remove this constant of proportionality, to remove this sign of proportionality, we can insert a constant of proportionality G. G is known as universal gravitational constant. So G into M1 M2 divided by what? R square, where G represent universal gravitational constant, universal gravitational constant. Remember, as far as universal gravitational constant G is concerned, from this expression G is equal to F R square divided by M1 M2. What is the unit of force? Force is measured in Newton. Distance is measured in meters, so meter square upon M1 and M2. Both are measured in what? Kilogram. So it is kg square. So the SI unit of G, what is SI unit of G? Universal gravitational constant. It is a Newton meter square per kg square. Newton meter square per kg square. Similarly, you can write down, you can find out the dimensions of universal gravitational constant. How to find the dimensions of universal gravitational constant? It is equal to dimensions of force. What are the dimensions of force? 1 in length, 1 in mass, minus 2 in time. Dimensions of distance, 2 in length upon dimensions of mass, it is 1 in mass and again 1 in mass. So dimensions of universal gravitational constant G are, see here, 1 in length and 2 in length. So this is 3 in length, 1 in mass upon 2 in mass. When it comes in numerator, it becomes minus 2 in mass. So it is 3 in length, minus 1 in mass and minus 2 in time. These are the dimensions of universal gravitational constant. So here F equal to G into M1 M2 divided by R square will gives you universal law of gravitation in its what? Scalar form. You can also express the existence of gravitational force of attraction. Remember, gravitational force of attraction, it acts along the line joining the given two particle. That's why it is known as what? A central force. Remember, this is what? Long range force. It is a weak force as compared to that of what? The strong nuclear forces or strong electric forces. So, you know very well that between any two point particles or particles of masses m1 and that of m2, and if they are separated by a distance r, what is the gravitational force of attraction between two particles of masses m1 and m2 separated by a distance r? It is given as G m1 m2 divided by what? R square. But we know that force is a vector quantity. So we must express that gravitational force in vectorial form. For that purpose, here a particle of mass m1 and m2 which are separated by a distance small r. Let the position of particle m1 and m2 with respect to what? With respect to origin of three-dimensional coordinate system. Let r1 bar and r2 bar, they will represent the position vector which describes the position of first and that of a second particle. Then r21, it will represent the position vector, position of second particle of mass m2 with respect to m1. Position of m2 with respect to m1, it is given by a position vector r21 and it is equal to vector r2 minus of vector r1, which is also equal to what? Minus of vector r12, where what is this vector r12? R12 bar, it will represent a position vector of m1 with respect to m2. Position vector of first particle of mass m1 with respect to m2, it is given by r12 and it must be equal to r1 minus of r2 and it is a minus of r21. It means vector r12, if it is pointing from m1 to m2, r21 is pointing from m1 to m2, then r12 will point from what? m2 to m1. These are just the concept taken by author, which may be different for different author, but you must be clear that the magnitude of vector r12 or vector r21, position vector r12 and r21, their magnitude is same, and that is naturally the distance of separation between given two point particle of masses m1 and that of m2. Remember, the force acting on gravitational force, it is the mutual force of attraction, means both the body they will exert a force of attraction on each other. Force acting on m2 due to m1, gravitational force acting on m2 due to m1, let us denote it by vector f21. 2 means force acting on m2 due to m1, it is equal to universal gravitational constant g into product of masses of two particles m1 m2 divided by, because mod r12 equal to mod r21 equal to r, so square of its distance, into minus of r21 cap. It means it is a unit vector. It is what? A unit vector. Minus r21 cap, it is a unit vector pointing from m2 towards m1. Remember here, r21 cap, it is a unit vector. R21 cap is pointing from what? R21 cap, it is pointing from, it points along the direction of r21. So it points from what? Unit vector pointing from m1 to m2. Means minus r21 will point from what? Minus r21 cap, because here I have taken minus r21 cap. Again it is a unit vector, but it is pointing from m2 to m1. Pointing from m2 to m1. I had shown it by means of a red color, minus r21 pointing from m2 towards m1. Similarly, the force acting on m2 due to m1, that f21 cap, this force will act in a direction from m2 towards m1. See here, f21 bar, and it is shown by means of an arrow pointing from m2 towards m1. So f21 will also act in the same direction as that of a unit vector minus r21. So whenever you have to write the vectorial form of force acting on m2 due to m1, it must be equal to g m1 m2 upon r square into what? A unit vector minus r21 cap. Similarly, you may write down what is the force acting on first particle. This is the force acting on second particle m2 due to m1. Now the force acting on m1 due to m2, it is f12 bar, and it must be equal to g m1 m2. No change in mass of particle, no change in distance of separation between them, so divided by r square into, because it is a force acting on m1 due to m2, so it must be multiplied by a unit vector r12 cap. Remember, it is quite simple to memorize f12 r12, only thing is what? Negative sign, and it is a unit vector. So r12 cap minus r12 cap, it is a unit vector pointing from m1 towards m1 to m2. f12 cap, it is a force acting along the direction from m1 to what? m2. Exactly opposite to that of what? f21. exactly opposite to that of what? Minus R21. So what here I can say? Magnitude of F12 is same as that of magnitude of F21. Means the force exerted on M2 by M1 or force exerted on M1 by M2, they are equal in magnitude, but they are what? Opposite in direction. Equal in magnitude but opposite in direction. So F12 is equal to minus of F21. So that's why we can say that the gravitational force of attraction, they are forming action reaction pair of forces. They will act along the line joining the two particles. Now this is the case when we are having a system of only two particles. You may come across this situation because this Newton's law of gravitation is applicable for all the material object in the universe. Means you may have a system of more than 2 point masses. Let us consider one of the system of point masses consists of 4 point masses M1, M2, M3, M4. Then in that case, when you are having a system of point masses and you want to find out the resultant gravitational force on any one of the point mass, resultant gravitational force on any one of the point mass, then it must be equal to vector sum of gravitational force exerted by remaining all other point masses. Means here, if I say F1 bar will represent the resultant gravitational force on a point mass M1, and if F12 represent the gravitational force exerted by particle of mass M2 on M1, F13 represent the gravitational force exerted by what? Gravitational force exerted on first particle M1 by M3. F14 it represent what? Force acting on M1 due to M4. So F12, F13, F14, these are the gravitational force acting on point mass M1 due to point masses M2, M3 and that of M4. Then according to principle of superposition in electrostatics, you had studied that principle of superposition. Whenever we have to find out the gravitational force on one of the point mass due to what? Due to many other point masses, then the gravitational force on that single point mass, it must be equal to vector sum of the force exerted by different particles on that point mass, force exerted by different point masses on that given point mass. So here F1 is the resultant force on point mass M1. It must be equal to vector sum of force exerted by different point masses, F12 plus F13 plus F14. In general, you may have a system of n point masses, M1, M2, M3, M4, Mn, like this, M1, M2, M3, M4 up to what? Mn. And you just want to find out what is the gravitational force, resultant gravitational force on ith particle. And if I say vector Fi bar, it is the resultant gravitational force on a point mass, ith point mass, then it must be equal to what? It must be equal to Fi1 plus Fi2 up to what? Fij, where j takes value from 1 to n according to principle of superposition, vector sum of force due to what? Remaining particle. So the force acting on resultant gravitational force on ith particle is equal to summation of Fij. It is Fij is what? Force acting on ith particle due to jth particle. Here I is not equal to j, but j takes value from 1 to n. But j takes value from what? 1 to n. Now see here that as far as law of gravitation is concerned, Up till now we had considered that gravitational force is acting between what? The point masses. You may come across a situation that you are given some extended bodies like Earth, bigger one, extended, and a point mass A, and you are given a task, find the gravitational force of attraction between them. As far as this point mass is concerned, no problem. F is equal to what? G m1 m2 divided by r square. If I consider mass of Earth is m1, mass of point mass is m2, m1 m2 you know, but you don't know what is r. From where the distance of point mass will be measured? From this end, this end, this end, this end, like that. So in that case, you just consider that extended body Earth is made up of n point masses, say of values m1, m2, m3, m4 up to what? Mn, and measure the gravitational force of attraction between what? Gravitational force of attraction between those n particles. You take, if I say vector F1A, it is the gravitational force of attraction between point mass A and particle m1 of extended body. Similarly, F2A, and in this way, because that extended body is divided into n particle, so this will give you the vector sum of gravitational force between the n particles of which that extended body is made up of and a given point mass A, and that will give you the net gravitational force between what? Extended body and that of a point mass. So you can find the gravitational force in this manner also. You can find the gravitational force in this manner also. Now we will study some different aspect. The gravitational force of attraction. See here, you may come across a situation that you are having a spherical shape, thin spherical shell of uniform density. Density of shell is what? Uniform. That shell is thin, shape is spherical, and you were given a task, or remember, I will make a statement that the gravitational force of attraction, gravitational force of attraction due to hollow thin spherical shell of uniform density, gravitational force of attraction due to hollow thin spherical shell of uniform density on a point mass, anywhere inside that shell, point mass situated inside this shell is 0. Gravitational force due to hollow thin spherical shell of uniform density on any point mass situated inside that shell is always equal to 0. Now here there are two probabilities. That point mass may be situated at the center. Suppose here point mass is situated at the center O of that hollow thin spherical shell. It means, as far as this hollow shell is concerned, every point on hollow shell, they are at a distance r from it. Means every particle on a spherical shell and a given point mass at the center, they are equidistant. Means every particle of shell will exert a gravitational force of same magnitude. See here, if this is a particle of mass m1, particle of mass m2, m1 equal to m2, then the gravitational force of attraction between m1 and m, m2 and m, magnitude is same. One is acting towards this side, other is acting in opposite direction. Means the gravitational force exerted by the point particle on diametrically opposite position of that shell. They are equal in magnitude but opposite in direction, hence they will cancel the effect of each other. So what is the net gravitational force on point mass? When point mass is at the center, net gravitational force due to the particles of the shell which are lying on what? Diametrically opposite position is 0, and this is the case for all the other particles. Every particle will have another particle at its diametrically opposite position. Hence you can say when point mass is at the center, then the net gravitational force due to hollow thin spherical shell of uniform density is 0 due to symmetry. But this may not be the case. If point particle, rather that point particle to be at the center, you may have a situation that point particle is somewhere here. When point particle is not at the center, it is somewhere else, then the mass of the region near to the point particle, its mass is less as compared to that of what? That portion of a shell which is away from the point mass. And mathematically you can prove that if I say this distance is 1, this mass is 1 kg, then the gravitational force is proportional to product of mass 1 upon square of distance 1 square, that is equal to what? 1, that is equal to 1. And this remaining part, remaining portion which is whose center of mass is far away from a given point mass, mass of remaining portion is large, distance of remaining portion from point mass is large. If I say mass is 100, distance is 10, so that force is proportional to 100 upon 10, means it is again equal to 1. It means whenever point mass is situated anywhere inside a hollow thin spherical shell of uniform density, the net gravitational force on any point mass situated inside the hollow thin spherical shell of uniform density, it must be equal to what? 0. It must be equal to 0. There is one more concept, that suppose you are having either a hollow spherical shell or a thick sphere. You may have a situation, another situation, that the gravitational force of attraction between what? Hollow spherical shell. You may have a hollow spherical shell or a solid spherical ball or a solid sphere, both of uniform density. Whether you are having a shell or a sphere, solid sphere, they are of what? Both of them, they are having a uniform density. And you are given a task, find out the gravitational force of attraction between either a hollow spherical shell with a point mass situated outside it or a point mass situated outside the solid sphere. Then in that case, you just find out the gravitational force between a point mass and a particle of what? Either a hollow sphere or a solid sphere, and resolve. See here, this is one of the particle of hollow sphere or this is one of the particle of what? A solid sphere. So find the gravitational force between given point mass and a point particle of that sphere or a shell. Resolve that force into two components. One of the component is what? One of the component is along the line joining the given point mass and center of the shell, or line joining the given point particle and the center of the sphere. Resolve it into two components. One of the components, see here, this component is parallel to the line joining what? Line joining given point mass and center of the sphere. while the another component is perpendicular to the line joining center of the shell and that of what? Given point mass. Remember, all these perpendicular components, they will get cancelled, and only those components which are parallel to the line joining given point and center of the sphere, they get added, and that will give you the resultant gravitational force between a point mass and that of what? A hollow sphere or a solid sphere. Remember, in other words, you can consider that whether it is a hollow spherical shell or a solid sphere, you know very well that the net mass of a spherical shell or the net mass of a solid sphere is supposed to be concentrated at its point, that is known as center of mass. So whenever you have to find out the net gravitational force between hollow spherical shell and a point mass or a solid sphere and a point mass, simply calculate the gravitational force between point mass and center of shell, point mass and center of a sphere, point mass and a center of a sphere. So let us now consider how to measure that universal gravitational constant, measurement of the gravitational constant or universal gravitational constant G. You know that gravitational force of attraction between any two particles of masses m1 and m2 separated by a distance r, it is given by F is equal to G into m1 m2, and if I say the two particles they are separated by a distance L, then G m1 m2 divided by what? L square. We are interested in measuring the universal gravitational constant, and that can be measured if we measure the gravitational force of attraction between the two particles of masses m1 and m2 separated by a distance what? L. Means this G is equal to F into L square divided by m1 m2. So measurement of G is nothing but measurement of distance of measurement of what? Gravitational force between any two particles of masses m1 and m2 separated by a distance L. So for measurement of that gravitational force of attraction F, we will make use of a Cavendish balance, weight balance. This balance was used by a Cavendish. So with the help of Cavendish balance, we come to know or we can measure what is the gravitational force of attraction between the two particles of masses m1 and m2. So what this Cavendish balance consists of? See here. Look at this. A Cavendish balance, it consists of light rigid rod. This rod is rigid, its weight is very, very small. So a Cavendish balance consists of light rigid rod. At the ends of this light rigid rod, see here, small circles are shown. Actually they are what? They are the small spheres S1 and S2. Small spheres of lead of masses m1 and m2, means this is a small sphere S1 of mass m1 made up of lead. Another sphere S2 of mass m2, again it is made up of what? Lead. Where they are fixed? The two small spheres of masses m1 and m2, they are fitted, they are fastened at the ends of light rigid rod. The center of rod, that light rigid rod, it is suspended at its center with the help of a fine vertical metallic fiber of length 100 centimeter. Means we are having a metallic fiber. One end of metallic fiber is fixed to a rigid support, while the other end of metallic fiber is attached to what? Attached to the center of that light rigid rod. What is the length of that metallic fiber? Length of metallic fiber is nearly 100 centimeter, means 1 meter in length. As it is a metallic fiber, it is highly elastic in nature, means by any reason, if that fiber is twisted, that fiber has a tendency to regain its original shape and size. So, over that fine vertical metallic fiber, here a plane mirror is attached, it is fastened, it is stick. So, what is the purpose of attaching the plane mirror on that fine vertical metallic fiber? That with the help of, see here I have shown a lamp and a scale. It is known as, together it is known as what? Lamp and scale arrangement. In lamp and scale arrangement, a beam of light is allowed to incident on that plane mirror. From the plane mirror, that beam of light get reflected and it will produces the image of mirror on the transparent scale. That scale is center zero scale. Means, so long as fiber is in equilibrium position, when lamp is switched on, beam of light falls on mirror, image of mirror can be seen at the center of a scale. You can adjust the position of scale either towards left or right, so that image of mirror, you can coincide that image of mirror with center zero mark. Then, if this rod is twisted, rod is rotated due to certain torque, fiber get twisted. When fiber twists, then that image of mirror, it will move either towards left side or towards right side, depending upon in which direction this rod is twisted, rod is rotated. So the purpose of mirror is to measure the angle through which fiber get twisted. Angle through which fiber get what? Twisted. So let us consider that we are having two large sphere of lead, L1 and L2. These are the two large sphere, each of same mass capital M. Remember here, diameter of small sphere, if it is 5 centimeter, then the diameter of large lead sphere, it is roughly 4 times that, means it is 20 centimeter. So the two large sphere of lead, L1 and L2, each of mass M and diameter 20 centimeter, they were brought near to the small sphere from the opposite ends. We know that as far as gravitational force is concerned, we know between the two particles, between any two material object, there exists a gravitational force, and that force is force of attraction. Remember one thing, what force will do? Either it will push the object or it will pull the object. The basic property of force to apply, or it will either push the object or it will pull the object. Whenever force is force of repulsion, then it will push the object away. Whenever force is force of attraction, then it will pull the object towards it. Gravitational force is what? It is a force of attraction. Means it will pull the object. So out of two objects, the object whose mass is small, that object get attracted towards the object whose mass is large. So here we are having a large sphere of mass M. Two large sphere of lead, when they are brought near to the small sphere from the opposite sides, both these large sphere, they will pull the small spheres S1 and S2 of masses M1 and M2 towards it with a force which is known as what? Gravitational force of attraction. And if I say, look at this, small r represent the initial distance of separation between the center of large sphere and center of small sphere, means the two objects of masses M and small m, they are separated by a distance r. What is the gravitational force? Here, an object whose mass is large will attract the object whose mass is small. So here gravitational force is pointing towards that object whose mass is large. So what is this gravitational force? The gravitational force that exists between large sphere and a small sphere, it is given by formula F is equal to gmm divided by r square. M is mass of large sphere, small m it is mass of sphere, small sphere. R is what? The initial distance of separation between center of large sphere and that of what? A small sphere. It means at the two free ends of a rigid rod, one of the gravitational forces acting in this direction, other is acting in what? Opposite direction. Means the two ends of rod, they are acted upon by the two forces which are equal in magnitude, but they are what? Opposite in direction, and they are forming a couple. And moment of couple is nothing but torque. So the torque acting on a rigid rod, these two gravitational forces, pair of gravitational forces, they produces a torque known as a gravitational torque. This torque is known as what? Gravitational torque. And torque is nothing but magnitude of one of the force multiplied by perpendicular distance between them. See here, the two forces, they are separated by a distance equal to what? Length of that light rigid rod. Means the gravitational torque is equal to, what is the magnitude of force? See here, between a large sphere and small sphere, the magnitude of gravitational force is gmm divided by r square. So this is gmm divided by r square into L. So this gravitational force, what is the effect of this gravitational force? Due to this gravitational force, it will not exert any force on that rod. It will exert a torque on that rod. And due to that torque, that rod undergoes a rotational motion. Due to rotation of a rod, this metallic fiber by which that rod is suspended, it undergoes twist. That fiber gets twisted. When fiber starts twisting, see what happens. As far as the image of this mirror, initially when rod is stable, that image of mirror is coinciding with center zero mark. As soon as this torque comes into existence, rod starts rotating, fiber starts twisting. So the image of mirror, it starts moving in one direction, say towards right. So the process of rotation of rod and the twisting of fiber will be continued. Remember here, as far as this fiber is concerned, it is made up of metal which is highly elastic. Means that fine vertical metallic fiber, it has a tendency to regain its original shape and size just by exerting a restoring torque on a rod in a direction opposite to that of, means if rod is rotating in anti-clockwise direction, restoring torque will try to rotate the rod in what? Clockwise direction. So that restoring torque exerted by a fiber, restoring torque exerted by a metallic fiber, it is directly proportional to angle through which that fiber get twisted, or restoring torque is equal to K into theta. Here this K is known as torsional constant. K is known as what? Torsional constant of that suspension fiber. Remember, one can find out the value of torsional constant of suspension fiber just by applying a known torque. You may apply a known torque, say T1, to a suspension fiber. For a known torque, that fiber undergoes angle of twist, suppose alpha, then TR is equal to K alpha or that torsional constant, it is T1 divided by alpha. So you can measure the value of torsional constant K of suspension fiber just by applying the known value of torque, measuring the corresponding angle of twist of that fiber, you can find the value of K. So what is happening here? As soon as the two large sphere of lead, L1 and L2, each of same mass m, they were brought near to the small sphere on opposite side, both the small sphere, they get attracted towards the large sphere. Means two gravitational forces will come into existence, they are equal in magnitude, opposite in direction. Their line of action of force do not coincide, they are forming a couple, and moment of couple is torque, and as a result of torque, that rod rotates, and the restoring torque or the gravitational torque acting on that rod, it is GMM divided by R square into L. Due to rotation of rod, fiber get twisted, but fiber is elastic, so it will try to regain its original shape by exerting a restoring torque Tr equal to K theta. Remember that rotation of rod is continued, this fiber continues to twist at some stage. So for the occurrence of equilibrium, what is necessary? The magnitude of gravitational torque, when it becomes equal to magnitude of what? Restoring torque exerted by it, means when gravitational torque is equal to restoring torque. What is gravitational torque? GMM divided by R square into L is equal to restoring torque, means K theta, or G is equal to K into R square divided by M into what? L. M into what? L. K, and this is theta. Since value of K we had measured already by applying known torque and measuring its angle of twist. R, the initial distance between center of what? Large sphere and a small sphere is known to us. Mass of large and small sphere is known to us. Length of that light rigid rod is known to us. So simply by measuring the angle through which that suspension fiber is twisted, you can measure the value of universal gravitational constant. So you can measure the value of gravitational constant capital G or universal gravitational constant G, and the value of that G, it is found to be 6.67 into 10 to the power minus 11 Newton meter square per kg square. 6.67 into 10 to the power minus 11 Newton meter square per kg square. So this is all about how to measure the value of universal gravitational constant.